Assalamualaikum to all of you. For this video, I would like to present optical communication modulation. For the introduction, as we know, amplitude modulation uses the same scheme as AM radio. This simple technique often requires very low cost hardware. Two basic types of AM techniques include the baseband and RF carrier. In a baseband system, the input signal directly modulates the strength of the transmitter output, in the case light. In the RF carrier AM technique, a carrier with a frequency much higher than the encoded information. Varies occur according to amplitude of the information being encoded. In the fiber optic system, the magnitude of the voltage input signal directly translates into the corresponding light intensity. The figure 1 illustrates the operation of an AM system. In order to use AM transmission over optical fiber, there must be compensation for the optical link loss budget. This problem may be solved two ways: by taking advantage of some special property of the input waveform. For the video, the same pulse in an invariant that can be used to distinguish optical loss from signal level variation, or using a technique that allows the signal level to interpreted independently from optical loss. To accomplish this, one could send a pilot tune at a higher frequency that is above or below the frequency of the information being encoded.
I'm Halimatul Sada. Will present about result and analysis for without external modulator, which attenuation 25 dB per kilometer and 75 dB per kilometer. This is our design for this system. This is the transmission part, and this one is the transmission medium part, and this one is a receiver part. At the transmitter part, we have a CW laser with the frequency 1550 nanometer. Then the transmit signal will enter to the MZ modulator analytical. MZ modulator is an external modulator which makes it attractive for radio over fiber system. And then the pseudo random bit sequence generator will use to generate with a deterministic algorithm to predict and exhibit statistical behavior similar to a truly random sequence. Then the transmit signal will enter to the RZ pulse generator. RZ pulse generator used to form of digital data transmission in which the binary low and high state transmitted by voltage pulse. The output for RZ generator is in electrical signal. Then for oscilloscope visualizer used to analyze the waveform of signal. Next, for transmission medium FSO channel. FSO channel is a free space optics use transmission medium and low power laser as light source. Now, at the FSO channel, we identify the range in 5 meter and the attenuation in 25 dB per kilometer. And then the signal will enter to the PIN photodiode. PIN photodiode used to convert lights into an electrical current. And then the transmitted signal will pass to the low pass basal filter. Low pass basal filter is type of analog linear filter with a maximally flat which preserves the wave shape of filtered signal passband. And the last one is the transmitted signal will go to the receiver part at the 3R regenerator. 3R generator will re-amplify, reshape and retime the signal. Okay, next, we use the BEI analyzer to identify the graph for I diagram and a Q factor for each sweep iteration and the distance range within 0 and 5 meter. And the sweep iteration from 1 to 6. Then, as you can see, the table for the maximum Q factor, I height and threshold, is slightly different. As you can see, the maximum value of maximum Q factor at sweep iteration 4. Meanwhile, the maximum value for I height at the sweep iteration 3. Then the threshold, the maximum value for threshold at the sweep iteration 4. Next, this one is for attenuation 75 dB per kilometer. At the FSO channel, we change the attenuation 75 dB per kilometer. Then as you can see, the graph for I diagram and Q factor for each sweep is slightly different. And as you can see, I have a spike at the graph for Q factor for each sweep iteration. Then, as you can see, the value for maximum Q factor, same with the 25 dB kilometer at the sweep iteration. Meanwhile, the I height also same. The maximum value of I height also same at the sweep iteration 3. Same with threshold. The maximum value of threshold also at the sweep iteration 3.
Okay, hi, I'm Nashavika Najia. I will discuss the result obtained when the electrical amplitude modulator inserted to the circuit. This electrical amplitude modulator is put between RZ pulse generator and MZ modulator analytical. This AM will modulate the signal of pulse amplitude generated from the RZ pulse generator. The frequency of the AM modulator is set to 5 MHz and 25 MHz with attenuation of FSO channel is set to 25 dB per kilometer. The output from the electrical amplitude modulator and CW laser is the input of MZ modulator. This MZ modulator will produce optical signal. Okay, this is a graph obtained for frequency of 5 MHz of electrical amplitude modulator. As we can see here, there are no difference in graph pattern for all sweep iteration from 1 to 6. Next is table for maximum Q factor, I height and threshold. Maximum value of Q factor is 6015.9, which is at sweep iteration 2. While maximum I height is at sweep iteration 3 and maximum threshold is at sweep iteration 2. Okay, next is the circuit when using 25 MHz of frequency of electrical amplitude modulator. This is a graph obtained for 25 MHz frequency. There is spike in each of graph. Okay, this is a table for result obtained. Maximum of Q factor, maximum I diagram, and maximum threshold is all at sweep iteration 2. As a conclusion for this part, when the frequency of amplitude modulation change, the Q factor for transmitted signal also change, while I height and threshold remain constant or have very small changes.
Hi, I'm Nur Ainan and we continue with optical amplitude modulator. For optical modulator, it does not need MZ modulator like electrical modulator because the output signal already in optical. Based on this graph, the spike for optical is higher than electrical modulator and without modulator. For attenuation 25 dB per kilometer, the maximum Q factor, I height and threshold is at sweep iteration 2. While for attenuation 75 dB kilometer, the maximum Q factor is at sweep iteration 5. The maximum I height and threshold is at sweep iteration 2. Minimum BAR for all sweep iteration with and without modulator is 0.
Now I will be proceeding with the discussion of the topic. The simulation was done with 6 sweeps and each sweep increases the range from the transmitter to the receiver. The attenuation of the free space optical channel was set to 25 dB per kilometer and 75 dB per kilometer respectively. From the table obtained, we can see that at 25 dB per kilometer attenuation, the Q factor increases with the increasing range between transmitter and receiver. Relatively, at attenuation of 75 dB per kilometer, the value of Q factor is slightly lower than at 25 dB per kilometer. The maximum Q factor increases with the increasing distance was caused by low amount of loss that was set at the free space optical channel. Also, the higher the value of Q factor, the less susceptible the signal to noise. Next, the frequency of the signal at amplitude modulator was tested. The frequencies that were tested are 5 MHz and 25 MHz. From the table obtained, the Q factor decreases with the increase of range. The same goes for the simulation at 25 MHz frequency. The relationship between the modulator frequency and Q factor can be described as inversely proportional. With the frequency increase, the value of Q factor decreases. A wave of a particular amplitude will transmit more energy per second if it has a higher frequency, simply because more waves are passing by in a given period of time. Therefore, the more power that is transmitted, the higher the attenuation, as the power are more susceptible to be lost to the surrounding.
Hello, I'm Muhammad Shahin. I will be conclude this assignment. From the assignment, students learn to design an outdoor OWC link based on parameters using specific modulation techniques. Next, to familiarize the software based on experiment given, students managed to complete the simulation and discuss the modulation formats with direct detection. Lastly, students analyzed and evaluated the performance characterization of the system based on specific modulation. That's all from me. Don't forget to subscribe and hit the like button. Have a good day. Thank you.